In this section, we will discuss controlling system services. We have seen the systemctl status command can show us the status of a systemd unit, specifically here the Bluetooth service. On the loaded line we see that it's enabled, and on the active line we see that it's active and running. Following that we see the main process ID. We can even use a PS command in order to verify that that process ID is indeed running. 1683 is the process ID. I'll look for it with the P option, and I'll give a little bit more detail with the U option. If a configuration file is changed, I often need to restart a service in order to reread that configuration change. Systemctl can be used to start and stop services. I can stop the Bluetooth service. The PS command can verify that it is no longer running, as can the systemctl status command, showing on the active line that it's now inactive and dead. Note that stopping it manually on a running system does not change what will happen when I reboot. On the loaded line it is still enabled, and the system will attempt to start this service at boot time. With systemctl start and the name of the unit, I can start the service. I can now look at the status, and I have a new process ID, 1871, of this running service. I can also restart a service with systemctl and the restart command. This will stop and then start that service. If I look again at the status, I should see a new process ID. It is now 1876. Some services can be reloaded instead of restarted when their configuration file is changed. Systemctl has a reload command which will trigger for the service to reload its configuration file. Not all services allow this. In the case of Bluetooth, we get a message that reload is not applicable for this particular unit. Let's look instead at the SSHD. I'll look at the status first for SSHD. I see its main process ID is 1304. If I use systemctl reload on SSHD and look at the status again, I still have the same process ID, 1304. There is an additional process that's been run. It's executed a kill -hup. This is a common method of telling a server service to restart or reread its configuration file. Additionally, in the logs, I see the message that the OpenSSH server daemon was reloaded. So this particular service does allow the reload option. Some services have dependencies. If I look at systemctl with a status on the cups service, I see that it is running. If I use systemctl with a stop command on cups, it will stop cups, but it gives me a warning that it can still be activated by cups.path or cups.socket. Cups.path, for example, is monitoring the print queue directory. If a file appears in that directory, it will activate or start the cups printing service in order to print that job. If I want to stop cups completely, I would need to stop all of the units that are related to the cups service. Remember that stopping a service does not keep it from being started again at reboot. That was the enabled feature or disabled feature. Systemctl has a disable command in order to disable a service. If I disable cups, it will remove the symbolic links associated with cups and its dependencies, so the service, the socket, and the path. What services are started at boot time are handled through configuration directories and links to the unit files for startup. Systemctl disable of the SSHD service has only the one service file to remove. If I look at systemctl status on SSHD now, on the loaded line to the right I see that it's disabled. But again, disabling a service does not have any effect on the current running system. So my SSH daemon is still active and running. Systemctl enable SSHD would enable this service so that it will be started at boot time. It does so by placing a link back into the correct configuration directory. Disabling a service disables it from being started at boot time, but does not prevent an administrator from manually starting it on a running system. Occasionally that is necessary, usually for conflicting services. If you want to completely disable a service so that an administrator cannot also manually start it, we mask that service. Systemctl mask command can be used to do this. iptables is a firewalling service that conflicts with firewalld, so it's a common service to be masked on a system. Here the link that has been created is a link to dev null, so if the service is started, nothing happens. If I look at systemctl status on iptables, I see on the loaded line that it is masked. And so the unit file that would be used to actually manage this service is pointing to dev null, and there's no information there for anything to be started. To unmask it, I use systemctl unmask, and again I give the name of the unit that I want to unmask. It removed that dev null symbolic link, and if I look at the status, I see that the file now is for iptable services. It is still disabled, so it will not start at boot time, and since it was not running, it is also inactive. So the systemctl command, in addition to looking at the status, can be used to manually start, stop, or restart services, in some cases also to reload those services. To make sure a service does not start at boot time, we disable the service. Or, to make sure that it does start at boot time, we enable that service. And if we want to completely disable a service so that it also cannot be manually started on a running system, we would need to mask that service.